Thank you so much to everyone for coming to this week's webinar. Apparently, my brain thinks it's Monday. My name is Jennifer Abel, and I am the training coordinator with the Portage Network. And welcome to our webinar on enhancing collaboration and reproducibility using GitHub and distributed version control, presented by Jay Brodeur. This is the third webinar in our co-presented series with Global Water Futures. This series aims to educate researchers and data professionals across Canada on research data management best practices and tools that are available to support them. These webinars will help participants navigate the evolving RDM landscape as funders, publishers, and the research community increasingly require good RDM practices. A little bit about today's webinar. Distributed version control systems such as GitHub provide researchers with a powerful tool for managing the processes and outputs of collaborative projects. Though commonly associated with computer code, systems like GitHub can be used to manage and share a wide range of products, including data, metadata, documentation, and even books. This webinar will introduce you to the fundamental concepts of distributed version control and will demonstrate how these can be applied in a research context using GitHub and its associated tools and interfaces. We'll cover how to create and control access to repositories and organizations in GitHub, how collaborators can clone, pull, fork, and push changes, and how repository owners can merge changes and manage versions. Finally, we'll review how repositories and their contents can be packaged into releases and deposited to repositories like Zenodo to support reproducibility and transparency. Before I go on, I'd like to acknowledge that the land to which I'm speaking to you from is the traditional, ancestral, and unceded territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, and Tsleil-Waututh nations. A couple of housekeeping things before we get started fully. You have been muted automatically when you entered the room. We can unmute you during the question and answer period, but we won't be doing it before that. This webinar is being recorded and the chat may be archived for those who are unable to attend. We encourage you to use the latest version of Zoom so that you have access to all of the features, including security updates. Please use the chat feature if you're having technical difficulties or have additional resources to share. And please use the Q&A option, which you'll find at the bottom of your screen, to ask questions of the presenters. Questions will be addressed at the end. You can also raise your hand if you wish to ask a question. Questions may be asked in English or in French. Code of conduct, you can find the complete code of conduct at the website on your screen, which will also be in the chat shortly. Carl and the Portage Network are committed to providing a welcoming, safe, and harassment-free environment for its staff, membership, committees, and working groups, as well as for participants, speakers, and organizers of Carl meetings and events. We do not tolerate harassment of any kind. Now I'm going to hand it over to Jay Brodeur, who's the Associate Director of Digital Scholarship Services at McMaster University. He's also Administrative Director of McMaster's Lewis and Ruth Sherman Center for Digital Scholarship. In his role, he collaborates with groups within and beyond the library to develop services and infrastructure that supports research at McMaster. Jay, the virtual pixelated floor is all yours.
All right, thanks, Jennifer. Let's see if I can navigate this appropriately. Can you see my screen okay?
Looks good.
All right, great, thank you. So I'm going to keep it like this for a little bit because I'll be bouncing around between windows. So thanks for the introduction, and thanks everybody for just providing me with an opportunity to talk a little bit more about version control, GitHub, and how we integrate it into the research landscape. I don't think I can cover, I know I can't cover everything that there is to talk about with all these subjects. I'm hoping I've hit some nice middle ground here, and it's enough to, for those of you who are new to this, to bring you in and kind of get your toes wet. And for those of you who worked with this before, think about a little further how this integrates with and supports research. So I'm presenting from virtually from McMaster University. So I'd like to acknowledge that McMaster University sits on the traditional territories of the Mississauga and Haudenosaunee nations and within the lands protected by the Dish with One Spoon Wampum Agreement. Okay, so learning objectives for this. This is what I hope you come away with, that at the very basic level, you're able to explain the purpose and function of version control systems. So what are they? Why do we use them? You'll feel comfortable applying a variety of tools, whether that's Git or GitHub or GitHub Desktop, to manage file versions within a repository. that you're able to apply best practices for officially managing and sharing those repositories. And then a bit of an understanding or some thoughts about how systems like these can be used to support research, collaboration, and transparency. And then if you are in a role where you provide support to a group or an organization, maybe you leave with a few ideas of how you can better support that where you are. But first, a few questions for you. So Jennifer is going to paste into the chat here a Mentimeter link. And I'm going to try to conduct this here as well. So you'll see a link, I believe, at the top. So if you go to menti.com and use the code that you'll see in the chat there. There's a few questions that I want to ask everybody just to get a sense of where you're at in terms of your understanding of what we're covering today, what you really want to get out of this, and then also thinking about, you know, maybe there are some pieces at the end of this that you're still interested in, and so we'll do a follow-up at the end. And if there's lots of interest in certain pieces, I'd be more than happy to, you know, do a follow-up presentation or meet with some of you and talk about some other things as well. So, I was just starting to worry that it wasn't working. So I see some numbers coming up here now. So first question is generally I'm interested in learning about. So do you want to just understand the basics of version control and for code and data, how to get started with Git and GitHub, how to integrate it into your work and to others' work, and how to support it at the institutional level. So I'll give it a couple more seconds here to see how this all shakes out. But it's looking like a pretty even balance of wanting to know generally a bit about each, and that's good news for me because that's kind of where I've tried to structure this presentation. So I'll give a few more minutes for folks to put in their votes here. All right, so that's great to know. I'm going to switch to the next question now. At least I think I am. Here we go. Okay, so this one I want to know a little bit more about your familiarity with version control and with Git and GitHub. So you've got a range of responses here from this is all new to me to I'm willing to swap you out, Jay, and I will do the rest of this webinar. I'll even share my slides with you if you want to do that. Okay, so we've got a pretty decent mix, and maybe skewing a little bit more towards those who know about them but haven't used them before, or they're familiar with them and they've used them. So, but we've also got some folks that this is all new, and that's fantastic, and some that you've heard these words before and kind of want to see them in action. So that's great. Thanks everybody. That's really helpful. All right, so let's go to the next one here. One more, and then we'll get the show on the road. So for those of you that have used or interacted with GitHub specifically, I'm curious about how you've done so in the past. So whether you've viewed GitHub repositories, you've used it to download files of software, you've cloned or created repositories, or if you actively have used it to manage your work, your teaching, your research, any type of your activities. Okay, so it looks like majority of folks, like we saw on the last slide, have had some interaction with it, and it looks like a lot of the interaction, the taking things off of GitHub, whether it's information or whether it's files, and then we got some users here that have used it for its sort of cloning and version control kind of aspects. That's fantastic. So let's see if I can get us out of here then, and I will jump us back into the presentation. Okay, and so what I want to present today is along these lines. So I'm going to talk about GitHub, but I would like to talk about GitHub in its connectedness to other systems that altogether support more or less, you know, the research environment. So I'll first talk about local version control, and so we'll do a really quick primer into just how that works, why you'd want to do version control, what it looks like with Git, and what it looks like with tools like GitHub Desktop, and then we'll talk about more broadly how it links in with collaboration and deeper research support. And that's where things like markup and presentation come into play, thinking about connections with repositories. And then finally, at the end, we'll talk really briefly about some of the administrative tools that exist that you might want to think about if you're an administrator, you're in a support role at an institution. Okay, so here's what we're going to do. Version control systems, talk about what they are, why they're important. Do a little bit of Git and GitHub kind of introduction to the jargon. I want to make sure that when you leave this without being afraid of the terminology that's used to talk about what Git and GitHub are doing. Talk about managing collaboration. We'll show an example, a really nice example where you can use GitHub or GitHub's been used to share research results, and then we'll talk about the admin tools. Okay, so most of us are familiar with version control systems in some form, whether we would realize that or not. And you probably use them regularly in your local computer. So operating systems have version control systems. You can revert back to previous files in many cases, or you can restore your computer. There's all sorts of file backup clients, cloud services like Google Drive, Dropbox, OneDrive, all maintain version control, and this is how you can get back to version history as well. So I mean, this is an area that's advanced quite a bit in terms of local desktop version control over the years. So essentially, version control systems provide a method for keeping track of changes to a file or set of files, and whether that's computer code, data sets, documents, text files, any type of file, really, that's what we're talking about here. So there are many different ways to do it, both correctly and incorrectly. And one way to do it, and this is for many of us out here, we've spent hours or days of our life talking about why you might not want to do it this way, is you might have a directory and some subdirectories and some files. If you wanted to keep snapshots of your work as you did work, I mean, you could just make copies of files if you wanted to do that. And so you'd have multiple copies. Every time you made a change, you just save it to a new file name. Or you could just make a complete copy of the directory and just rename that directory when you've done something different there. And that could work. That could work for a while, but anyone who's done this on a relatively large scale for a long period of time knows that this is prone to errors. And so some of the errors that you're going to run into are, eventually you're going to write to the wrong file or folder. You're going to overwrite some files. You're going to misname something, or you're going to come back to some files in months or years and have no idea what they are and which one's the most recent version. You'll just keep forgetting to do it. And then even if you do it and you need to get back to the correct one, if you just have a whole bunch of files, it's going to be really difficult to figure out which one was the correct one you have to go back to. Basically, you have to hunt and peck through all of them. And this is where, you've probably all been in the situation where it's almost a trope, this PhD comic with file names and using file names to denote something about version to the point where it loses all meaning. So wouldn't it be nice if there was some way for the computer to do this for you, to take these snapshots when you want to take snapshots and give you some tools to help you version through this a little bit better? That's what version control does. And so one approach to this is local version control. And so in this case, there's a database locally on your computer that records changes when files are made over time. Ideally, the system is easy and mostly automated. It would allow you to quickly compare previous versions and recover to old states. Of course, this doesn't help you if you need to collaborate on files like computer code or data sets or documentation or anything like that when others aren't using the same computer or have access to the same file system. You could try to adopt conventions and share the files back and forth, and you've probably been on email threads where everybody's adding their initials to the end, and then eventually someone takes the wrong version of that email and edits that version, and now you have two versions and you need to merge them together. You could do that, but you probably want a better solution. So this is where centralized version control comes in. And so in centralized version control, it's a solution for collaborative editing and versioning of files. So in this approach, a single remote server holds all the version files, and anyone that wants to edit it would check out that version while they're working on it. So this helps manage the collaborative editing part in a way that keeps track of who made what changes, and it allows granular access of controls as well for who can edit what. The downsides of this approach is that everything lives on that server. So if you lose connection to it, or if something goes wrong with the server, you can't do your work. depending on the system, you may also be locked out of a document while someone else has it open. I know we run into this here with Dropbox and Word docs, where if someone has it open, then the other person can't edit it, and we end up with versioning controls, versioning issues all the time because of it. So this is where distributed version control systems like Git and GitHub come in. So instead of checking out single files from the servers, clients or the users will clone, so they'll mirror the entire repository, so the collection of files and folders and all the versioning information that's in the versioning database as well. So they clone all of that from the server, and it gives the user the ability to make local revisions in their local repository. So those changes made locally are tracked locally, and then if there's a desire to send those changes back to the remote server, they can be pushed back, and the version control system is able to compare the databases to understand what's changed. If the changes can be easily merged together and not cause any conflicts with the files, then it will just do that automatically. If there are conflicts, then this is where someone has to intervene in order to mindfully merge those two together. So this provides a better approach in that it allows for this collaboration and concurrent development. It allows you to give granular permissions to who can do what with these files, and there's no single point of failure either. So it's easier to you take this repository, do your own stuff with it, and now you have a copy and they have a copy, and as long as we can at some point get that back together, if we need to, then that's all good. Okay, so here's the why you should use it. It took me a long time to get there, but I've gotten here. So distributed version control software lets you and your collaborators track, compare, revert changes, and it does this quickly and with granularity, which is nice. It lets you manage collaborative development. It lets you deal with the challenges of scale, essentially. So as you add more files, as you have more changes, as you have more collaborators, your needs for keeping track of versions increases significantly. It lets you share materials, whether that's openly or in a controlled manner. It allows for collaboration or reuse, and then, importantly, it backs up your work to an external repository, so you don't have a single point of failure. And Jennifer mentioned in the introduction that these systems are not just for computer code. Often we think about them as computer code solutions, but really they can be used to manage all sorts of things. And I've linked to examples here where it's been used, of course, to manage code. So the code for OpenRefine is developed and managed on GitHub. Data sets, all sorts of data sets you can find that are version controlled and shared on GitHub. Documentation, so the data curation, network curation primers are a really good example of this documentation. Books, there's a whole book on Git from the bottom up that you can find on GitHub, hosted on GitHub. And then websites, and then pointing to the UBC Research Commons Intro to Git web pages. So you can actually host web pages there too, and I'll talk about that briefly in a few minutes. So just to talk about what two of the tools that we're going to talk about in a minute. So Git is a free and open source distributed version control system that can handle anything from small to large projects, and it's robust. It's been around a long time. You run it on your local computer, and then GitHub is a web-based hosting service for version control using Git. So it's the functionality of Git, but hosted on the web with a bunch of extra collaboration and management tools that are added onto it. And so that's a relationship between these two things. Okay, so let's go through briefly. I don't want to get into too much depth. I'm going to link out to some tutorials later on, but let's talk about basic workflows, what this looks like in action. And I'll start by talking about in Git. So the first piece of terminology that I think we should talk about is a repository, defining what a repository is. So in this context, it's a set of files or directories that you want to manage with a version control software. And so when you want to spin this up, when you want to get Git working on a repository, you're going to initialize it. And so whatever your working directory is, you just initialize Git there. It creates a hidden folder that has a .git extension to it. And inside of there is the database, and it basically sets up all the materials it needs to track any changes that you make to that file going forward. And you can initialize a repository in a directory with content in it, or it can be completely empty, and you can bring that in later. So that's one way to do it. And I've showed you, I've got the commands in green here. If you want to just follow along as I do this, this is what you would actually type into the command line interface in Git. You could also clone. So you could find a repository that exists elsewhere on GitHub, for example. And with a command, you can point it to that repository and pull those materials in. And now you have a local version of that repository that you can work on. Some tips here. It's always good practice to create a README file that you create at the time of initializing it. This will become the README file for your repository. And think about it creating a license file as well. And we'll talk a little bit more about license files and what you should think about when you're doing that soon. And then it's time to do your work. So you would do your work locally in that directory. However you would do your work, you're editing files, you're working with some, I don't know, programming approaches, you're going to make changes to these files. And so it's important to note that with something like Git or with GitHub, that these snapshots that you make are intentional. So the changes aren't going to be tracked until you actually take a snapshot of them. So you can change a bunch of stuff around, and it's not until you're actually ready to add or update those files that you are going to take a snapshot. So both of these are done with the add command, but I've kind of separated them out. So you have to tell Git which files or which directories you want it to track. And you could tell it everything in a directory. You might just want to tell it certain files to track. You might want us to keep track of your scripts, but not worry about the data files. For example, the data files might be big and they might be static and you don't have to worry so much. So you have control over what is actually tracked. And using the add command is telling Git, it's instructing Git to begin keeping track of the file versions. At the same time, if you're already keeping track of it, but you wanna stage it to make another snapshot, then you would update that file. And then when you're ready to actually take that snapshot, when you've staged it with adding it or updating it, then you're going to tell it to commit. And so when you do that, you're actively saying all the files that have changed that are being tracked by Git, I want you to take a snapshot of those files. And you usually do that with some sort of message and then optionally a description afterwards. And these are important because these are little nuggets of wisdom to yourself to remind yourself of what you were doing at the time when you were taking the snapshots of those files. And those can come in handy very often. There's also shortcuts where you can add and commit at the same time, and I've kind of shown that what that code looks like down there. Okay, so you've done it. You've taken a snapshot. Where do you go from here with it? And so there's a couple different options. So you can continue to work on it, add and commit, and you can manage all that locally. And you will have a working version control system on your local system. If something goes wrong, there are methods for reverting your changes and getting back to where you were before if you need to. There's also nice tools for comparing differences between files so you can actually figure out where something changed or when something changed. But you may also want to do some more development. So you may have developed, a set of scripts and data, and it works really nicely. All your analysis runs well. You want to try some new things, but you don't want to actually mess up what you already have. And so in this case, this is where you can create a branch. And so a branch is essentially a copy of files and directories that live within the same repository, but it's a separate copy that then you can work on and experiment on and test out things. And you can continue on with multiple branches and just keep going, or at some point you may want to merge it together. So you're working on an updated set of scripts to do some analysis and make some figures. In that case, you will work on it till you know it's working well, and then you'll go about that merge process. And there's some tools in Git and GitHub that will help you actually merge those two pieces back together again, so everything's back on the main branch. You may also want to move outside of your local repository, and so you may want to push those changes to a remote repository. One example is GitHub. There's other examples out there of similar types of platforms. GitLab is another one. Atlassian has their own too. So there's all sorts of options. So when you push, you're going to send those modified files and the Git database and everything back up to the remote repository. And so this allows you to do a number of things. So once you have it as a repository in GitHub, you can disseminate it, you can share it. You can let others who are your collaborators modify and contribute to your work. You can manage those contributions as well. So you decide when people make changes, you can decide what ultimately gets merged onto there. So you can have the final say on the management. And then, overall, you can manage changes and control development. So that's the reason why you would want to use a remote repository other than, having another copy somewhere of that repository. And this is where we start to get into this collaboration piece. So you can do a lot of these edits inside of the GitHub interface as well. So like I said, GitHub essentially has Git running in the background. And so you can add files, you can edit files, you can add and commit. And usually that happens at the same time in GitHub. And you can branch and merge. And so everything I showed you in Git is all done mostly through the GUI, the graphical interface inside of GitHub. So it should be a little more intuitive. There's also a really nice tool called GitHub Desktop. And so this would, in many cases, would replace what you need to do with Git. And so it's a graphical interface that would live on your own system. And you can use that to do the adding, the committing, the pushing, the polling, and merging and all those types of things instead of having to use the command line on your local computer. So it's worth checking out if you're interested in this kind of stuff. Okay, so let's move on to the next piece and talk a little bit about how we can manage collaboration, access, and sharing inside of GitHub. So number one, when creating a repository in GitHub, you're going to have some options in terms of what that repository looks like and who would have access to it. So when you create it or clone a repository, you're going to give it a name and a description. Of course, the more understandable the name and the better the description, the more findable and the more understandable it's going to be by others. You can set visibility, so you can set it to be public, available to anyone. They can see what you're doing, they can clone it, or private, where only you and your named collaborators can have access to it. And then you also have the option to create a README file, to create a gitignore file. I won't talk too much about that right now, and also a license file. And then then you would go about doing your, your uploading, your adding, your committing, et cetera, et cetera. Okay, so thinking about repository visibility. So you can get to this anytime in settings if you want to change your mind after you initially create something. So things to think about here is public to everyone. There's really no option about that. They can clone. They won't have the rights to actually overwrite your repository, but they will definitely have read access. You can set repositories to be private, and that would allow collaborators or defined teams to contribute to it, to see it and contribute to it. And then just a note here that there's more private features. There's more features with a private repository if you have the paid account or if you're within an organization, I believe. So you might not see a lot of options in terms of managing access in private repositories. This has changed a little bit over time. It used to be you couldn't even do private repositories with the free account, but GitHub has since opened that up a little bit. All right, next thing to think about would be adding a license. And so I think that's a topic for another webinar about which license do you want on your materials. But just know that there are a bunch of built-in licenses when you go to the license selector here. So you can choose one of these licenses and you can review it. You can also add your own. So you can paste in terms from other licenses if you so choose to do so. And then actually adding collaborators. So from the settings page of your repository, you can add collaborators to your public and private repositories. For personal repositories, these are ones that are owned by a user. So if you have your GitHub account, you create a repository inside your GitHub account. If you bring a collaborator on, they can push pull and also fork. So they can read, write, and fork your work and work on it on their own. They can also manage pull requests, I believe. So they do have a little more authority over your work. If you want to get into more granular permissions, then you think about building an organization and adding folks to an organization. And that's what I want to talk about right here. So this is something to think about. If you're setting up a research group with this, there's lots of benefits from having a single person own the repositories and just adding people versus creating an organization. So just the group of shared accounts for projects, and having the repositories belong to those organizations. So once you do that, you get all these benefits that I'm showing here. So you can have shared ownership of as many repositories as you want. You can also have top-level management of repositories for the organization owner. You can add as many people as you want. You can be quite granular with roles and permissions. So different repositories within that organization can have different permissions. You can have different groups within there that have varying permissions, whether they can read, write, or add comments, etc. You can also create teams within the organizations too. So you can have groups of people and give that custom access to that group of people as well. You can enable two-factor authentication. So if you're collaborating on repositories and you want to make sure that the right people are contributing to your work, then you want to think about enabling something like two-factor authentication as well. And very nicely, they're free to create an organization. So it's not restrictive in that way, which is really nice. We run our own organization here in the University Library McMaster, where we have over the last few months worked to bring all of our repositories into here, and so we have much better management of everything that we do in terms of development in the library. I'm going to skip over this slide. It'll be here in the slide deck for you. It just provides a little more information on how organizations and teams kind of work together with each other. Okay, so you're at the point now where you've created your repositories, you're working together, and you have some shared products that you've created. Now, one of the things by its very nature is that these repositories are dynamic because your contributors could be polling your changes, making changes, pushing those changes back up. This is all well and good for doing this kind of development and active work, but there comes a time when you want to take a sort of a snapshot of that repository at a certain time and share that out. And this is when you want to create a release inside of GitHub. And so all a release is just a tag snapshot of a repository, and you use it for deploying a discrete version to audiences. And you might think about, if you're developing software, if there's a certain version that is stable and ready to deploy and you want to keep working on it, well, you make a release and you share that release out. You might package things up as a supplemental material to a publication, for example, and so you want to link to the repository at a certain point in time. And then I'm going to provide an example here in a second about archiving in data or code repositories. And so this is where this is important. You want to bring a repository into you want to bring a repository in GitHub into another data or code repository and archive it and preserve it. You don't want to do that with a dynamic object. You want to have a static object that you can bring in. So here's an example of archiving in Zenodo, and maybe let's see if I can minimize full screen here for a second and just show what this looks like. And so this is the Yahoo Knowledge Graph COVID-19 data sets. This has been deposited in Zenodo, and the source of this comes from this GitHub repository here. And so here is where the entirety of the repository exists. And so there's one subdirectory that's data. You've got your license, you've got your README file, and the README file shows up immediately on the GitHub page. And if you know Markdown, and if you use Markdown, then you can create nice stylized content. And so this is a really nice way of putting those README documents right in people's faces when they come to your site. And so, I mean, we can take a look at a couple different pieces here. If we wanted, we could explore some of the insights and see the nature of the commits. We can see that the last commit was 2 hours ago, and that there's been 2,300 commits over time. So what we're showing in this case is actually a forked version. So if we were to click on this link here, what we're seeing is not a link to just the GitHub repository in general, but to a specific release that has been made. So someone's made a fork of this repository, and then they've created a release. And so at that point, that's when you would deposit that into a repository. And this is what the release looks like as an example. All right, so let's keep rolling through here and talking about things you want to think about to make GitHub a place where you can manage a lot of your collaboration. So there's a number of really nice tools that are built on top of the version control functionality. And so one of these is issues. So this is a way that essentially a ticketing system. So if there are issues with your code, and you can control whether your collaborators have access to this or anyone in the public can. So you can cast this net, you know, as broadly as you want in order to have people report potential issues or request features, and then within each issue, then you can manage and respond to that, so you can keep track of what needs to get done. There's also pull requests. So someone might fork your repository. They might make some changes to it. And they might say, this is a really nice improvement. You might want to think about putting this back into your repository, the main repository. And so to do that, they would submit a pull request. So essentially, they would submit their repository for you to review. And there's some really nice tools inside of GitHub that will say, whether or not it's really easy to merge these changes together. And if it's not, you need to go through and do some manual intervention to ultimately make that code work together. You can also, it's kind of like there's a Trello functionality in here, like a Kanban kind of board that you can use with projects, which is really, I haven't used it a whole lot, but I'd be interested to hear if others have integrated this and are using it. And there's also a wiki as well. So you have lots of means of keeping together all sorts of information about your project and your work, and also managing that work inside of GitHub itself. Okay, so let's go to the last piece here before we talk about broader organizational stuff, and thinking about markup and presentation. So I showed you that README file that was formatted pretty nicely, and that was all done using Markdown. So let's talk about using GitHub as the medium to share information about your project. So here's a really neat example, and it's neat not just because it comes from McMaster, but it's an interesting example because this is essentially a preprint of a COVID-19 paper that's been shared on GitHub, and so this is also submitted to a publication, and so it's linked here to the DOI. But essentially, this was used by the research team to coordinate their work, and so they've shared all their materials here, or majority of their materials, in their GitHub repository, and they've, using our Markdown and using just regular Markdown, they've created essentially in a marked up paper form their paper, and so they've included all the tables and equations and embedded images, and these images are hosted themselves in the repository, so it's all kind of a self-contained sort of document. So a really interesting idea for showing these results in the same place that you're building these results as well, and that's some of the potential for GitHub when we start thinking about integrating all these pieces together. Okay, and so I've mentioned Markdown a couple times. So those of you who are not familiar with Markdown, Markdown is essentially a really lightweight markup language used by GitHub, and it's used by many other sites as well. So if you get good at Markdown, you can use it on Reddit, you can use it on Trello to essentially do some basic formatting of text. And the nice thing about Markdown is that you use simple notation, so stars and hashes and dashes, for example, and the text that you create, the marked down text, which is on the left here, is still very readable, even when it's not rendered. So on the right here is when it actually goes through an interpreter, a Markdown interpreter, and shows up as very nicely looking rendered text. So it's kind of a hybrid between, like, the .txt README file that just has the bare information, but it's also able to present itself nicely for the web. Okay, and something else that that I've not shown to this point, or talked about to this point, is, all right, so we can create a nice Markdown file and we can show our results through there, but you can also host web pages on GitHub as well with a feature called GitHub Pages. And so it's essentially what it is a static site hosting service, and you can, if you know HTML, if you know CSS, you can use all those pieces. If you don't know those technology, it also has software called Jekyll incorporated into it, which means Jekyll can take Markdown. So you can write with very simple notation, and Jekyll will take that and it will render it as HTML pages. Let's see if I can bring up an example here really quickly. This is a GitHub page that I created as part of a workshop on GitHub pages. And so all of the content that you see here, these are all just Markdown files inside of a GitHub repository. You point GitHub pages in your settings for that repository. You say, look in this folder, all the Markdown information that's in here, turn this into web pages. And then you can create some very simple but pretty effective web pages where you can embed content. So if you have embed code from something, you can include it in there, and you can include hyperlinks and do a bit of styling as well. So there's lots of possibilities for thinking of not only building your data and your scripts inside of GitHub and having a really nice engaging README, but also thinking about you could turn that into a web page that shows those results as well. All right, last piece, and then we can have a little bit of discussion, hopefully. So talk about a couple of administrative tools that if you are involved in supporting teaching or research that you may want to explore a little bit and think about encouraging to other folks. And so one of these is GitHub Classroom. So GitHub Classroom is designed to manage a course. So it's like a weird LMS kind of thing, but it all works through GitHub. And so you add those students, the students in your class, to an organization, and then you can control, what rights they have to writing to other people's repositories or their own repositories even. You can create assignments from templates, and all this lives inside of GitHub. And essentially you can add deadlines to these submissions, and the submissions are the repositories themselves. And so the students submit those repositories, or at a certain time a snapshot of a repository is taken. And if you're really good at this, you can do some automated management and grading of it as well, depending on the nature of your assignments. You can unleash computational power on making it easier to manage websites. I've used this for classes. I've not done any of sort of the automated part yet, but it makes it a lot easier to manage access for a large class, for example. And then finally, something to think about for your campus. So there's a program called GitHub Campus Program. And so as you may be aware, GitHub is a Microsoft product and has been for the last couple years or so. And with this, they've rolled out something called the GitHub Campus Program. And so what that does is it provides institutions with access to GitHub Enterprise Cloud, which is a cloud solution GitHub, which is massive in terms of what it can accommodate. And essentially, this lets you institutions manage collaboration and access. So the repositories for groups, whether they're doing research, whether they're a support group, whether it's a class, all of these can live as separate organizations within the GitHub Enterprise Cloud. You can have an unlimited amount of organizations. There's access to GitHub Enterprise support to help you with that as well. And one of the neat things is that you can hook this in with your own institutional authentication as well to help manage these repositories and access to them. And so we're working on this at McMaster right now with our IT group to integrate this with our Azure ADS. And then hopefully we'll be able to roll this out broadly across campus with the help of our campus IT. And there's all sorts of premium features that people get access to, like continuous integration, which is important for code development. And then most importantly, it gives administrators with a single point of visibility and management. And so I've pasted the link down here where you can find a little bit more about that and start that conversation on your campus if you're interested in doing so. Okay, so I hope that was fairly connected in terms of, just introducing what Git and GitHub are, and then thinking about how they can connect together to support research more broadly. We got one final question here that I'm going to put out to you, if I can get back to my screen. Hold on a second. Zoom keeps blocking me. There we go. All right, so we're going to bring up Menti again, I think. All right, one sec, folks. All right, so I think this is working. So if you go, Jennifer, if you shared that, menti.com, and then the code is 3674978. I'll give you a few seconds here just to think about what else would you want to learn about. So what did I talk about today that is interesting but didn't cover enough depth that you would love to learn a little more about? What are some things that I didn't talk about that you would love to have as part of a conversation, or maybe a follow-up webinar or something like that? So I'll give you a couple minutes to add your thoughts. And I apologize if there's a crying baby in the background. Cranky time of day, I guess. All right, so I see kind of a variety of comments here about, some are very specific, how to take certain elements out of a repository, how to use tools like GitHub Classroom, how to use specifically GitHub, comments about needed to be hands-on. I would love to do a hands-on one. I didn't think this was the venue, and then I don't think I could give enough context in this webinar around Git and GitHub, and also do the hands-on part. But if there's lots of interest in the hands-on, I would be happy to do one where we all sit in this virtual space together and we work through it piece by piece. So let me know if there is interest. Okay, so more examples of team collaboration. So how would that actually work? And so we could build some examples of that. More depth in each area. Yeah. If others are interested, I would love to explore this more with, maybe if there's a group of people that kind of want to build some, little modules or something where we could do a deep dive into it. It's kind of the nature of these webinars. This is kind of the, the whet the appetite, talk about the top level stuff, and then we can always do a deeper dive from there. And I'm going to share some resources right after this, where you can do a bit more of a deep dive as well with some materials that are already existing. So I like this example here, this case study. So how academic research groups are actually using it. I would love to, it would be neat to have maybe a panel discussion or something like that, and bring together some groups and talk about exactly how they're doing and how they're managing the collaboration piece of it, and what's the value prospect that they see from it as well. Okay, so thank you everybody. We'll collect these and hopefully we can do something with it going forward. And so you'll see these slides as well. So here's a link to a few more resources in terms of where you can get some very detailed guidance. So the Git Pro book is amazing. It's absolutely fantastic. It's step by step, everything you'd ever want to do in Git. Same with the GitHub guides is really good as well. So I'd recommend that. And a shout out to the UBC Libraries Research Commons. They've got a couple guides up for getting into Git and GitHub. So I think that's it. That's all that I wanted to cover. So Jennifer, maybe I'll let you come back in. I'll say thank you. And if there are questions or comments or discussion, I'm here and happy to chat.
Thanks so much, Jay. That was great. And I think we all know there's a lot more we need to learn, but now we at least know where the starting point is. And we do have some questions, and I'll go first to the hand up in the chat, which is Dwayne Pinto. Dwayne, I've allowed you to talk, so you can unmute yourself and ask your question.
Hello, thank you. Good morning to all. Jay, that was great information. Obviously, Jennifer is on point, but I don't know a whole lot about your operations and systems. But what I want to know, if you may not be able to come up with everything on today, because what I'm going to ask you would take me over 4.5 years to even get to where I'm at with the Library of Congress and everybody else. But how can I work with your system in regards to, I'm in the entertainment industry out in Hollywood. So what I would like to do is I'm creating a new project, basically film, I guess you want to call it that, but I try to not talk too much about it. But how can I build up a system? I've already built up a group of people that I communicate with throughout several countries throughout the world, and how can I work within your system? I deal with a lot of different artists, people within the art, you know, some of the art that I don't do, but I'm a pretty good writer and actor and stuff like that. But how can I use your system within that, in regards to building up community, and what exactly, um, how would that prosper? I guess you all and myself, and what can I do to become better? I guess I'm asking. I know a little bit about the social media, but I'm not that good on that one. You know, just enough, I guess you could say.
Yeah, thanks, Dwayne. That's a really interesting question. It's fun to think about these kinds of things that maybe I don't think about all the time. Focusing on kind of research. I think it really depends on what your end goal is. So it sounds like there may be cases where you're collaborating with people. Of course, there's functionality on GitHub for you to build an organization and have use that to do some kind of project management or those kinds of things.
Right.
GitHub, I mean, you have the control about the visibility of your repositories, and so if there are materials that you want to share broadly, that it would be a way to share it. And if you think about building in, GitHub Pages to have a front side web page to that as well, you could pretty quickly put together, a nice looking web page that is also fed by the GitHub repository in the background. And then thinking about,
Okay.
Is this a platform that you want to use to put some stuff out there, so people can find it, and then maybe bring in some collaborators because of that. And that's one of the things that you can definitely do with the nature of repositories and with GitHub.
Okay. So that's wonderful. So what you just said.
Nope, I think you went muted there, Dwayne.
Oh, I'm sorry about that. But
No
how
problem.
can I separate? Because I'm literally, what I'm doing, I really can't say it hasn't been done before, but this is 2020, so it has not been done. So let's get for real. So as I'm doing it, I want to try to reshape the industry that I'm in, which is called entertainment. As I do it, not only as I want to do it, I understand that people are in entertainment forums with every facet of entertainment that you can imagine. I want to build platforms from there and be a dominant power and structure with changing the industry. So that's my objective.
Dwayne, I think this is maybe a conversation that you and Jay can have in depth more outside of this webinar. We will be sharing the slides. So if you'd like to get in touch with Jay via email and arrange a chat, we can certainly set that up.
Yeah, I have no problem with that. Hey, look, for not knowing anything about where you all were coming from, I'm like, this is just like, wow, it's beneficial,
Great, that's
Yeah,
great.
thanks,
Thanks
Dwayne.
so much, Dwayne.
You got it. Thank you.
Okay, so we've got some other questions in the Q&A. We've got a question from Krisha, who's with Global Water Futures. Are there Canadian-based GitHub servers if server location is a concern, or do organizations host their own servers? Thanks.
Great question, Krisha. So the answer, organizations can host their own servers. So thinking about something like GitHub Campus Program, this is one of the stumbling blocks that we're running into, is that right now all the servers are in the US. We do know that Microsoft has been mindful of moving servers into Canada, and so for things like Teams and OneDrive, for example, have now gone to Azure Cloud that are based in Canada. For right now with GitHub Campus Program, it is in the US. You can host locally with GitHub Campus Program and with GitHub repository in general. You can definitely do that. And this is where I would give a shout out to some of the research support groups across campus, across your campus or across many campuses that are hosting very similar types of platforms. So GitLab is another example of an open source version control software system that works very similarly to GitHub. It's basically a fork of what GitHub was. And those are hosted locally as well. So if you're thinking about getting into this and you have questions about, where this data has to reside, it's worthwhile asking around to see what's available in terms of different options, because I have a sense that many or most campuses will have a couple different options available. Thanks, Krisha.
Thanks. We have another question from Pascal Martinoli. Do you have a recommendation for point-and-click software to manage Git? Because the learning curve could be less steep.
Yeah, absolutely. This is where I would recommend GitHub Desktop. So I would download that, install that, and that's pretty much an interface-based Git-like management system, and you can integrate, you can install Git, and you can integrate it with Git on your own local machine as well. And so that gives you most of the functionality of Git, and also integrates really well with GitHub.
Great, thanks. So just some terminology clarification. So an organization in Git or in GitHub would be any group of people that you want to put together?
That's correct, yeah. So it would be essentially a group of GitHub accounts. So if individuals create GitHub accounts, then you would create an organization. So I should back up. An organization is just an entity, is just a thing. And you add people to the organization. So you may have one owner of the organization, that may be you, and you may have a bunch of members, or you may have multiple owners of a single organization. But you add individuals to the organization by their GitHub account. And then within that organization, then you can start to get more granular with teams. Yeah, we run into this problem trying to explain this at the campus, because we're talking about organization, and all this terminology kind of overlaps with each other in terms of what we're actually saying. I hope that clarified.
Yeah, I think that's great. Thanks. Another question, since GitHub is a Microsoft product, what legal ownership do they have over any researcher code that is hosted in their servers?
This is a great question, and I don't have an answer. I would love to. Maybe I'll do a deep dive into their terms of services to see if anything has gone in there since they've taken over control from what was GitHub before. I don't know. Great question, though.
Yeah, definitely an interesting thing to get into. Possibly a scary thing to get into as well at this point. Yeah.
Yeah.
A question from Jennifer, not me. If I understood correctly, you mentioned all McMaster University repositories were brought into GitHub. Could you elaborate on that?
To clarify, that the university library repositories were brought into GitHub. So we stumbled across this. So David Biofolk, individual in the library, came across this and brought this to our attention, and we thought this is a great solution, because right now we have repositories. We ran our own Git repository locally, and we were putting things on GitHub. And so we identified this as a really nice solution. So we brought this to our central IT, and we're working with them, and we were the pilot group. So we went about saying, all right, let's get all of our repositories that are scattered everywhere and start to bring them into that single organization, which is the university libraries organization. And we've kind of modeled this out, and we've brought this back to the community and said, here's what this can look like for your organization to create an organization.
Great, thanks for that. Any other questions? I'll just give a quick reminder that we will be sending out the slides of Jay's presentation to everyone who registered, as well as the link to the video on YouTube, which will be going up in the next couple of days. So if you have any further questions, as I mentioned, Jay's contact info will be available, and you can get in touch with him directly. Last call for questions. Well, thank you so much, Jay, for everything. That was a really interesting presentation. I think I need to go and start diving into Git now and learning about all of these things.
Well, thanks, Jennifer. Thanks to everybody. This was fun to do. Hopefully we can do more.
Yes, and hopefully, yeah, we'll hopefully have you back again for more webinars. And we will have another webinar tomorrow on the abstract field in data repository information, and one next week in the Global Water Futures series on Cuisinart and Casper. So hopefully we'll see you at both of those. And in the meantime, until then, enjoy the rest of your Tuesday and your October.